Hello. Here is Fenglan and Shijun who on the project of Bayesian time series on electricity. So basically, our research question is to use past electricity data to predict future electricity usage. Um, and our motivation is basically like so our previous exposure to time series analysis are always frequentist methods, but we want to try Bayesian methods. And also, electricity prediction is of significant policy implications because accurate models could help providers balance loads and reduce utility costs. And also, the Bayesian modeling is a perfect fit for time series analysis because it continuously updating beliefs based on the observed data. And our data set is basically a hourly data set on the energy column, on the electricity usage, expressed in the energy usage. And our data set covered the data from 1998 April to 2002 January. So basically our source is to split the data set into a training set and testing set. We we use the training set to feed the model and use the testing set to predict. And because the data is non-stationary, so it depends on time. So we need to include a local trend effect and seasonality effect based on daily, weekly, and monthly times, and also our core regression, which is run using a dynamic regression and the error term. And the local component basically follows a random walk with randomized error. And the seasonality is daily, weekly, and monthly. The dynamic regression, because we think the electricity usage is depends heavily on the winter and summer, because during winter and summer there are always more electricity usage. So we include the indicator variables of winter and summer. Yeah. And as mentioned before, like the seasonality expression is decomposed into the daily, weekly, and monthly. And each of the seasonality is further decomposed into the past data plus a randomized error.
Okay, so I will introduce the dynamic regression expression. So here is our mathematical expression for the whole dynamic regression model. As Shijun mentioned before, we have two predictors, which is a dummy variable for indicating if it is a winter, or and a dummy variable kind of like indicating whether it is a summer. So each of it will have a coefficient of beta and gamma as the spike and slab prior, which will be mentioned in the next slide. So what's going to evolve as time goes on is the coefficients of the two predictors. As you can see here, for each time t plus 1, and it would be the coefficient of the previous time plus a variable that is given a prior from a normal distribution. And as for the spike and slab prior, which is the gamma we mentioned here, and it is a mixture distribution trying to indicate when a predictor comes into effect. So it just consists of two parts, the slab part and the spike part. The slab part represent a broad prior for coefficients that are likely to be non-zero at a given time t, which is the blue distribution here. And the spike part is a narrow prior centered at zero for coefficients that are likely to be irrelevant at a given time t. So in this way, the regression component could be dynamic instead of static, which means that, well, the eighth winter predictor is only come into effect, which is the slight part when the month is kind of like January and February. But it is also going to be zero, which is becoming the spike part when it's in other months. And that's basically our model. And if you are really interested into how our results or how the model could kind of like predict the electricity, just please visit our poster during the poster session. Thank you so much.